Hi guys! Today we're going to start chapter 2. This is our first chapter. There will be 3 videos for this specific chapter. So before the end, make sure you've watched 3 videos. They're going to be generally between 20 and 30 minutes. Some are shorter than others. But for this one, you will need a calculator, so make sure y'all have got one. So the first part of this one is about scientific notation. I know you've seen scientific notation before. It may have been a little longer than I would have hoped. So let's just briefly break down scientific notation. Remember that there's 2 parts to a scientific notation number, and it's the decimal part and the exponential part. For the decimal part, it has to be between 1 and 10, and it needs to be one number here. So it needs to be 1 through 9. Before the decimal. The number of numbers after the decimal doesn't matter. For the exponential part, the exponent itself, the times 10 is always there, but the exponent itself must be an integer. So it can be a positive or a negative number, or it could be 0. So this slide is for standard notation. Okay, from scientific notation to standard notation. Positive exponent means you multiply your number by 10 to the positive number, and this will result in a large number. So this is sine notation to standard notation. Okay, the negative exponent means it's a very small number, so you're dividing by 10 to that number, and those will always result in a smaller number when you've got that negative exponent. Going from a standard notation to scientific notation is a little different. So this is standard to scientific. Okay, so these large numbers, again, remember they have positive exponent, small numbers have negative. So for large numbers from standard to scientific, the decimal moves, however many times it moves, it'll move to the left. So this is for large. Small will move to the right, the decimal will. Okay, remember the decimal goes between the first 2 non-zero numbers. So let's do a couple of examples. So this is a very large number. So I've got 3.15, and then I do times 10. I'm going to do 3, 6, 8 times 10 to the 8. And this is people. Don't forget your units. In science, we almost always have a unit. So if there's a word that goes with the number, you do need to go ahead and write that. So here we've got another number in standard notation. Again, the decimal goes between the first 2 non-zero numbers. And I've got 3, 6, 9, 12, 13. Don't forget your unit for this one is that $sign. Now we've got small numbers. So I've got 7.0 times 10 to the negative 11 meters. And here I've got 3.8 times 10 to the negative 5. This one specifically doesn't have a unit, and that's okay, but just make sure the exponential part that you're counting how many times it moves. One thing before we go from this, just remember the calculator. Either if you have a scientific calculator, the TI-30XXIS, or the TI-84 or 83, all of those have a mode to put it in scientific notation. Okay, and if you need help with that, just let me know when we do our meetings, and I can help you get it to and from that notation. Now let's talk about uncertainty, and this is going to lead us into significant figures. So uncertainty is always indicated by the last digit. This is very important. Students normally miss questions on this. So it's important to know the uncertain digit is the last one. This is the one that I'm estimating when I'm looking at instruments. So we're going to look at some different instruments, and then we're going to do some practice problems on them. If we were in a real lab setting, you would also practice that. I'm going to have y'all do some virtual practice with that on a lab. But once we get into the classroom, if we get back into the classroom, you'll get to experience some of that. It is important to know that the greater the precision, the greater the number of sig figs. So here, as you see, this balance is measured in grams, and just every 1 gram. But we estimated this 0.2 because in the image over here on the right, it's just over 1 gram. So I'm estimating it at 1.2 grams. This balance measures to the 10th place. So we have to estimate the 100th place. You always estimate one past what the instrument can read. So here, I've got 1.12, so it's just past the 1.2, and it's about halfway. So I would have probably said 1.25 grams. It's okay if your estimated digit doesn't match exactly. The certain digits do need to match because you need to be able to read the instrument properly, but the estimated digit, as long as you have one, it's okay. So here, we've got this scale. I do want you to know this picture is a little hard to see, so it's going to be a little different. I would say this is 147. We know it reads to the ones, so I need to estimate the 10th place. I would say this is 147.5 pounds because it's about halfway between 147 and 148. Again, this picture is not the best. They're saying it's 147.7. Okay, it's perfectly okay if you have 147.5 or 147.7. Really, as long as you have this number as an estimated number, I'm okay with whatever it is, as long as the certain ones are fine. This one also reads to the ones. There's my 103. It's a little above that. I would say this is 103.5 degrees Fahrenheit. They're estimating 103.4 degrees Fahrenheit. Again, it's perfectly fine if your reading isn't exact, but it needs to be exact in the certain digits. Remember, only the last digit can be different. So that leads us into significant figures. Significant figures will be used the entirety of chemistry, including this class. If you take AP chemistry, if you need chemistry in college, sig figs are very important. I do also want you to know sig figs come about in physics as well. And we're going to use it all through chemistry. So I really need you to know this because we will continually use them every time we see a number. Okay, so I need you to commit this to memory. I do understand we're online now, but we're going to use it so much you're going to know them. The first one is all non-zero digits are significant. That means if the number is not 0, it's important. Number 2 is what I call the sandwich rule. This is that interior zeros are significant. So this is a number in between, a 0 in between two other numbers. So that 0 is sandwiched in between two other numbers. Okay, when that is the case, it's significant. Rules 3 and 4 are about trailing zeros. Trailing zeros are the zeros at the end of a number. So let's say 500.0, and then let's just say 5,000. Okay, 3 does have a decimal. The zeros are to the right of another number. If there's a decimal, they're significant. So all 4 of those numbers for number 3 are significant. Number 4, if there is no decimal, they are not significant. So this is only 1 sig fig. And this is 4 sig figs. Number 5, leading zeros are never significant. Those are the ones in front of a number. So if I had 0.0005, the only number that counts is this 5. So this is 1 sig fig. Because all of the zeros in front don't count. They're leading to another number. And then the last rule is that if it's in scientific notation, everything before the time sign count. Doesn't matter how many numbers I have in front of the time sign. They are all significant. So let's do some practice. A, we've got leading zeros. They do not count. So this is 2 sig figs. B, we've got a sandwich rule 0. That one does count. And a trailing 0. So for the trailing 0, you need to ask yourself, is there a decimal? If there is, and it's after another number, the 0, it counts. So B is 4. C is also 4 because there's no zeros. D, everything in front of the time sign counts. We're going to skip E. I'll come back to it. F, trailing zeros, there is a decimal, and the zeros are after another number. 5, and then G is 1 because there's no decimal. E follows this rule. Exact numbers have unlimited sig figs. If you see this equal sign, that means it's a conversion factor. And we're going to talk more about that in part 2 of the video. But conversion factors have unlimited sig figs. It is very important to note unlimited sig figs if you see that equal sign. In this example, so this is unlimited. That was the one we skipped, unlimited. Okay, so let's do some more. Here we've got 4 because there's no zeros. Those are the only ones that count here because there's a decimal. 2 for the time sign. D is unlimited. After the decimal, trailing zeros count. So this is 3, and then F is 2 because there's trailing zeros, no decimal. Here it is going to say ambiguous. That will not be the answer on any quiz or test question that you see. Now we're going to talk about rounding. What's most important is this. You do not round until the very end of all of your calculations. So if you have multiple steps, you do need to make a note, like a mental note, if you need to write it down on your physical notes. Whatever's in your calculator stays until the very final answer. Okay, we are only going to look at the answer, just the number, just to the left of the one we're keeping, and that's the only thing that we're using to round. And remember, it's 5 or more, erase a score, 4 or less, let it rest. So instead of round down, you should know this, I'm going to say keep the same if it's 4 or less. So here's where we need our calculator. We're going to talk about multiplication division rules. You do need to count the sig figs of all of them. The one with the fewest total, that's the number you keep of sig figs. So that may be a little confusing. It's okay. What you need to do is count 3 sig figs, 5 sig figs, 2 sig figs. That means I'm only keeping 2 because that's the least number of sig figs in my problem. So these are the ones I'm keeping. This 0 keeps it the same. 45 is our answer. 4 sig figs, 3 sig figs. That means we're keeping 3 total. So remember, leading zeros don't count. This 9 is going to round that 5 up. So it's 0.966. Now let's do these problems. The biggest thing you need to do first is count the total. So I've got 3, 2, 4, 2. So then I'm going to write down the number that I get when I do the multiplication and division problem. Don't forget to type it in properly. I get 0.067556 Okay, so that's everything that my calculator shows. I'm keeping 2. So these are the 2 I'm keeping. Then you look at the digit right after that. 068 because the 5 rounds it up. For B, I've got 436, so I'm keeping 3. $1.51863041 I'm keeping 3. So I've got 1.52 is my answer because that 8 rounds the 1 up. So just make sure you're looking at only the number after the one you're keeping. Okay, let's do these. I've got 3, 3, 4, 1, 2. Okay, so you look at all of those. I'm only going to keep one. It comes out to 0.0010775. It does keep going, but I'm only keeping one, so it's 0.001. I've got 4, 6, 3. So I'm keeping 3 for that B. Got 0.203822, keeping 3, so it's going to be 0.204. Just make sure, only look at that one directly after it. For addition and subtraction, we're going to focus on the fewest number after the decimal. So this one isn't the total, we only care about after the decimal. So here I've got 2 after the decimal, 3 after the decimal, 3 after the decimal. I'm only keeping 2 because you always keep the fewest. 1, 3, we're keeping 1. So here I've got 3, 1, 2, 3, 3, 2. So from this first one, we're only keeping 1 after the decimal. I get 124.867. So my answer is 124.9 because the 6 rounds my 8 up. For B, I get 8.664, and that's negative. I'm only keeping 2 after the decimal. That's negative 8.66. So all we're focusing on is the numbers after the decimal. So for A, I'm only going to keep 1 after the decimal. So this one's going to come out to 7.6. It was 7.588. For B, I'm keeping 2 after the decimal. So it's going to be 131.11. Make sure you do round these if you need to. The last step is combining them together. Don't forget PEMDAS. You do need to go in order of PEMDAS. So parentheses are going to go first, and then your exponents, multiplication, division, and then lastly, addition and subtraction. Remember, you can't get rid of numbers in the middle. You need to keep those values in your calculator. Oh, okay. So I've got to do parentheses first. So I'm going to do that math. I get 0.479. But from that math, I'm keeping 2 after the decimal because that's the sig fig rules. So when I do my multiplication, this last number now only has 2 total sig figs. So I get 19.1707. It does keep going. I'm keeping 2 numbers, so this is 19. B, this one's a little harder. We're going to do the parentheses first. I get 4.9464. Sig figs. I'm keeping 2 total, which gives me 1 after the decimal. So 1 after the decimal, this is what the calculator says. It'll be 14.7. So whatever the last rule you're using out of PEMDAS, that's the number you're keeping. But you do need to keep the rules together. So notice I did my addition subtraction rules on A first, and then I applied those to the multiplication. On B, it was the opposite. I did my multiplication rules, total, sig figs, and then I applied that to the subtraction. If you need more practice, you are more than welcome to do those. And if you need more practice on anything, please reach out. Okay, that is it for this video. If y'all have any questions, let me know. Y'all have a great day.